What is normal data? What is data? Data is a collection of information, and this could be about anything: house prices, sport results, the weather, or about people. You are full of data. In statistics, we call these different attributes that we have in our data variables. These are some of the variables that could describe you. But all variables are either what we call categorical or they are metric. Categorical variables are variables that are in fixed categories or buckets. For example, your gender, what kind of coffee you like to drink, whether you use a Mac or a PC. A metric variable is any variable that contains some sort of numbers. For example, your age, how many minutes a week you spend watching TV, your height, your weight, and the mark you get on your exams. What is normal data? Whenever we collect metric data, we end up with a variable with a whole lot of numerical values, and we are able to plot this on a graph and look at it. Sometimes our data takes on the shape of a bell curve. This is what we call normal data. In normal data, the values are clustered around the average value in the data, which we call the mean in statistics. In this example, the mean value in the middle of the bell curve is 4 hours. Another term that we use in statistics is standard deviation. Standard deviation is a value that tells us about how varied the distribution of data is. You don't need to know how to calculate it, as SPSS will do that for us. In this example, the standard deviation is 1.5 hours. Now that we know about normal data and we know these two statistical terms, mean and standard deviation, we have the tools to calculate if any value is typical or not. Glenda introduces us to this theory in the textbook. It's called the 68, 95, 99.7% rule. I'm going to simplify that to just the 95% rule because it's less of a mouthful and also because 95% is what we most typically report in this unit. The 95% rule says that in any normal set of data, 95% of all values will be within 2 standard deviations of the mean. This means that only 5% of our values should be outside 2 standard deviations, 2.5% above this and 2.5% below this. Let's have a look at an example from the textbook. Say that we asked 100 people how many hours of television they watch each day, and we've got all their answers recorded in a spreadsheet. We input this spreadsheet into SPSS and then use it to calculate some statistics for us. SPSS tells us that the mean number of hours of television watched per day is 4 hours, and that the standard deviation is 1.5 hours. Our data fits into this nice bell curve pattern, so we know it is normally distributed. The 95% rule tells us that the TV viewing of 95% of the 100 people that we spoke to is in with 2 standard deviations of the mean. In this example, with a mean of 4 and a standard deviation of 1.5 hours, our 95% range is between 1 and 7 hours. Therefore, we expect that 95% of the people we spoke to watch between 1 and 7 hours of TV each day. A person whose TV viewing fits into this range will be considered typical in their TV viewing habits. If a person is outside this range, we'd say that their TV watching was unusual. One thing that you will need to be able to do in this unit is to calculate exactly how many standard deviations from a mean something is. This is known as a standardized value, or the z-score, as we'll call it in this unit. The z-score is how many standard deviations away from the mean a value is. If we look at somebody who watches 5 hours of TV a day, this is 1 hour above the mean of 4. 1 hour divided by our standard deviation of 1.5 hours is 0.67, and so our z-score is 0.67. The z-score doesn't have any units. It's not 0.67 hours, it's just 0.67. If a z-score is above 2, then we know it's unusual. In this case, because the z-score is less than 2, we can conclude that a person watching 5 hours a day is within our typical range. If we look at a person who doesn't have a TV and so watches no hours of TV a day, then this is 4 hours below the mean. Minus 4 divided by our standard deviation of 1.5 is minus 2.67. So the z-score is minus 2.67. If the z-score is below minus 2, then we know it is unusual. In this case, we can conclude that a person that watches no TV a day is unusual. The negative sign is very important in a z-score, as it tells us if a value is above or below the mean. After we've calculated a z-score, we should do a double check to make sure that we've got the negative or positive sign correct. If the value we are interested in is below the mean, as it was in this case of 0 hours, then the z-score will always be negative. Otherwise, if the value is above the mean, then the sign will be positive.